Welcome to Python Data Classes, a beginner's guide. If you have ever written a Python class just to hold data, you know how tedious it gets. Data classes solve that problem completely. In this tutorial, we will go from zero to confident, step by step. Let's write less code and do more. So, what exactly is a data class? Ifcontrue is a regular Python class decorated with the @dataclass decorator. The moment you add that decorator, Python looks at the type annotated attributes you defined and automatically wires up the init, repar, and EQ methods for you, completely for free. Watch the code on the left. We define a student class with just two attributes, name and grade. No init method written by hand, no repar formatting. Then we create an instance with student, passing name equals Alice and grade equals 10. When we print it, look at the output on the right. Python gives us a clean, readable representation. Student name equals Alice, grade equals 10. That is the power of data classes. 2 lines of attributes, and you get a fully functional class. Let me show you the difference side by side. On the left, you see the old way of writing the same student class. It takes 11 lines of code. You have to manually write the init method with self.name and self.grade. Then you write repar so the object prints nicely. Then you write EQ so you can compare 2 instances. All of that is repetitive boilerplate. Now look at the right side. The data class way. 6 lines. That is it. Same result, same functionality, but a fraction of the code. And that is only the beginning. As we add more features, the gap only gets wider. This is why data classes have become the go-to choice for any class that primarily stores data. Sometimes you want a field to have a sensible default value, so the caller does not always have to provide it. It works exactly like function parameters. Look at our employee class. Name and department are required fields, but isActive has a default value of true. So when we create an employee with just name and department, Python automatically sets isActive to true for us. Watch the output on the right. Now, here's an important rule to remember, and this trips up many beginners. Fields with defaults must come after fields without defaults. This is the exact same rule Python enforces for function parameters. If you put a default field before a required one, Python will raise a type error. Here is a common beginner trap. You might try to set a list or dictionary as a default value directly, like students equals an empty list. Python will reject this with a type error. The reason is crucial. If you did allow it, every single classroom instance would share the exact same list object in memory. Adding a student to one classroom would accidentally add it to every other classroom. That is a nasty bug that is hard to track down. The fix is to use the field function with default factory. Watch the correct code on the left. We write field default factory equals list. Now, every classroom instance gets its own fresh, independent list. The same pattern works for dictionaries and sets. Just replace list with dict or set in the default factory argument. One of the nicest free features you get with data classes is automatic equality comparison. Python generates the EQ method based on your fields. 2 data class instances are considered equal if all their fields match. Let me show you. We create 3-point objects. P1 is at coordinates 3, 7. P2 is also at 3, 7. And P3 is at 1, 2. Now watch what happens. When we compare P1 equals P2, the output is true, because both points have the same x and y values, but P1 equals P3 returns false because the coordinates are different. With a regular class, you would have to write this comparison logic yourself. Here, Python handles it automatically, field by field. What if you want an object that cannot be changed after it is created? That is where frozen equals true comes in. Pass frozen equals true to the data class decorator, and Python makes every field immutable. Look at our color class with red, green, and blue fields. We create an instance with values 255, 128, and 0 that is an orange color. Now if we try to change the red value to 100, watch what happens. Python raises a frozen instance error. The assignment is completely blocked. Frozen data classes are perfect for things like coordinates, colors, configuration values, or any data that should stay constant throughout your program. They're essentially lightweight alternatives to name tuples. Sometimes you need to compute or validate something right after the object is initialized. That is what the Post-Init method is for. Look at our rectangle class. We have width and height as input fields, but area is computed from them. Notice that area uses field with init equals false. This tells Python, do not ask the user for this value. We will compute it ourselves. Then, in the Post-Init method, we calculate area as width times height. Watch the execution flow. We create a rectangle with width 5 and height 3. Post-Init runs automatically, computing area as 15. When we print r.area, the output is 15.0. You can also use Post-Init for validation, like checking that an age value is not negative and raising a value error if it is. Data classes support inheritance just like regular classes, and it works very cleanly. Look at our animal class with name and species fields. Then we define a pet class that inherits from animal, adding just one more field, owner. When we create a pet instance, we need to provide all three fields, name, species, and owner. The child class automatically includes the parents fields in its init method. Watch the output on the right. Python gives us a complete representation with all three values. One thing to keep in mind, if the parent class has fields with defaults, the child class can only add fields with defaults too. You cannot put a non-default field after a default one, following the same parameter ordering rule we discussed earlier. Data classes integrate beautifully with the rest of Python's ecosystem. The asDict function converts any data class instance into a plain Python dictionary. Look at our book class with title, author, and price. We create a book instance, then call asDict on it. The result is a regular dictionary with the same keys and values. From there, you can pipe it into JSON.dumps to get a JSON string. Watch the conversion pipeline on the right. Book instance through asDict becomes a dictionary, through JSON dumps becomes a JSON string. This is incredibly useful when you're sending data to an API, saving to a file, or working with a database. Data classes make serialization almost effortless. Let's put everything together with a practical example. A shop order system. We have an order item class with product, quantity, and price. The total field is computed automatically in Post-Init by multiplying quantity times price. Then we have an order class with a customer name, a list of items using default factory, and an isPaid flag. The order has two helper methods, add item appends to the items list, and grand total sums up all item totals. Watch the execution. We create an order for Alice, add a notebook at 2 units of 4.99 and 5 pens at 1.50 each. The grand total comes out to 17.48 and is paid as false. Clean, readable, and almost no boilerplate. Data classes are great, but they are not the right tool for every job. Here are 3 cases where you should avoid them. First, if your class has complex behavior or logic, a regular class or a service class makes more sense. Data classes are for data, not behavior. Second, if you need strict validation on every field assignment, consider using Pydantic instead. Pydantic is built specifically for that purpose, with powerful validators and type checking. Third, if you are working with dynamic attributes that are not known at class definition time, data classes will not work for you. As a rule of thumb, if your class is mainly storing data with maybe a few helper methods, a data class is probably a perfect fit. Here is a quick reference cheat sheet of everything we covered. The @dataclass decorator is your starting point for any data class. Default values work just like function parameters, but remember to place them after non-default fields. For mutable defaults like lists and dicts, always use field with default factory. Never use an empty list directly. Frozen equals true makes your instance immutable, perfect for constants. Post-Init lets you run logic after creation, great for validation or computed fields. Field with init equals false skips a field from the constructor. As Dict converts to a plain dictionary, ideal for JSON serialization, and inheritance works just like normal Python classes. And that is Python data classes from start to finish. They strip away the boring, repetitive parts of writing classes and let you focus on what actually matters, your data and your logic. Give data classes a try in your next project. You will be surprised how much cleaner your code becomes. If you found this helpful, hit like and subscribe for more Python tutorials. Happy coding!